Hello, sports fans. Mauricio here. Well, we're using arrays to build data sets. Question is why? And the answer is because we don't like writing queries that have 4 table joins or 6 table joins. And a lot of strange things can happen when things are too complicated. Just like, how can you get 6 friends to agree on what to eat for that night's dinner or entertainment? So 6 table joins, etc., are wicked hard. But if we put the data in an array, you load a couple of columns with the dimensions, and then you could load each column one at a time, which is pretty easy, actually. Some of the code's a little esoteric, but you could load each column one at a time. You don't have to have one superstar group by query or whatever that brings in numbers like from 5 different data sources all at once. So we're not trying to win the fight with one punch. We're being systematic here, and so we use arrays, and we fill the columns with numbers, and then we use update set commands to manipulate the numbers, and then drop all the array into a new table. So you could save the array into a permanent table. So we use the array as our canvas to merge data, perform data transformations, do a lot of calculations. And then it's very common to save the array into a database table for permanent storage and to publish it, and so that other analysts can connect to that compiled data set with their Excel or whatever program they need to use. So DBAs make the data sets that the rest of the company uses to analyze the business. Of course, there's other ways of doing this, such as buying $5 or $10 million ERP software, but we are building the data sets. So the DBA builds the data sets for other analysts. So the DBA is a better paying job. So let's learn about this. So again, we create the array, then you insert data into the array. So we're going to get the 2-dimension columns from this AW products flattened table. We are bringing in the data for the French totals, but we're doing that with a subquery, so we'll have to talk about that. But you build the array, you load a few columns, and then you start loading the rest of the columns. So I'm going to load the Germany column, and if there were 5 other columns, I'd load them one at a time. And then maybe we'll have a totals column, etc., and then start doing some metrics and data transformations. It's all possible, and you have a fighting chance to get it done if you use an array. If you use a series of subqueries or CTEs, and I've had analysts show me 9-level CTEs or 9-level subqueries, just like a finance person may have nested if statements inside their cell. Things get complex fast. However, I believe if you use an array, you don't have to think 9 levels deep. You just put the right data in the right column and then deal with it one column at a time. Add 2 columns together and make a ratio or whatever. But load the array, perform transformations, and then save the array back to a database. I call that publishing. And so we'll run this, and then we'll see if it actually saved the table. What we'll see, however, is this is a very common way to build data, but it's not the best for producing reports, charts. data visualizations from this type of column, column, column. But, this is a very popular type of report. It kind of looks like a crosstab. So the data is kind of easy to see. If you took this data, I'll have to do it, I suppose, now that I'm talking about it. If you took this data into Excel or Power BI, you can use conditional formatting to make certain columns pop out, like this particular Mountain 200 for the French totals is, for some reason, there's an awful lot of cells there. So, I mean, that number, that cell should be accentuated somehow. All right, so let's talk about the data. So the scenario is at the end of the month, each of 6 country managers are uploading data using the same procedure, and they upload a file with 4 columns as you see here. The data is at product level. We're gonna, in the array, analyze the data by model level. So when we bring the data in, you'll notice that we sum the column from the source data set. So we'll do it there, and then we'll do it here too. So the data is at product level, and so we can see there's 6 different products for model 200. But when we, so that's Australia. So when you see the model 200, if it was Australia, then you would have to remember that that is all 6 products for that model 200. So we're analyzing the data by models. How, why do we have so many darn products? These are bicycles. So it's a different size bicycle for people with different length legs. So they have the same model in different sizes, just like the same truck could be, different LE, SE, XSE, and all these different packages. So it's very often to have many different products within the same model. All right, so let's look at the code. So 6 country managers are uploading somehow, and now we at headquarters need to merge. Our requirement is to merge these 6 columns into a data set and publish it so others can connect to it with their Excel and do analysis that they need to do. So building data sets is one thing DBAs do. And a DBA is paid, 2 or 3 times as much as an analyst, until the analyst gets promoted into some director type position, and management positions always pay more than technical positions. All right, so we're making the array, and then we're going to start out with an insert into select from where, and so I'm going to get 2 columns from this AW products flattened table, and we should probably look at that. So and talk about why are we using this table. So let me just pull it up. AW products flattened. So the products is a hierarchy in this AdventureWorks table of 3 tables: products, subcategories, and categories. I went and flattened them. So the hierarchy, with their foreign keys and all that, is products, subcategory, and category. I got tired of writing join queries, so I made what's called the denormalized table and flattened the data. So a sign that you have a denormalized table is that there's lots of repeating values, and if we're doing data entry, this is bad to store the data like this. But if we're doing data retrieval or building analytics, the goal is to go as fast as you can with accuracy. But I want to get the models from that AdventureWorks, AdventureWorks Products Flatten Table. Why do I want to get the models for that from there? And we'll see if this works. But here's an analysis of the units sold by 5 of the countries. And we could see that, for example, for Australia, they only bought 5 or 6 of the models. So could we pull a list of models from the Australia data? No. Could we pull a list of models from any of these countries? Well, it looks like Canada purchased products that represent all the models. But that's just not a good way of building the data set. So we can see here that there are about 15 models, and they have different numbers of products. So we're condensing the products by model, and we're going to build a data set that kind of looks like what we have here. So we're getting the dimension tables from this dimension table, filtered for the subcategories that are bikes, and then we're putting in the French totals, and this is a subquery, and the subquery is totaling those units from the France table, and when the model for those units matches the model that we have in our array, then it sums the units and then stores it in that column. So we have a bunch of road 250s, but 0 units sold for road 150. All right, so at this point, line 17 down shows this first output that I have here. And so that's what we have so far. And then I wanted to bring in the Germany sales. So this is a correlated subquery inside an update, and that's pretty powerful. But what it means is, and please do more YouTube research, what it means is sum up the products from the German data set where the model in the German data set is in the list of models. So for the road 150, go ahead, for example, go ahead and add them up and go save it in the Germany totals column, but do it for the right row. And so we're going to see that a bunch of these rows are going to be populated, and it's pretty close to magic in my book. All right, so I wanted to show that you could fill the German column, but if you wanted to, you could also add more values to the totals column. So I'm kind of doing 2 things at once here. So let me run this again. I just had it highlighted. There was no problem with the code. All right, so the German totals have now been entered, and the grand totals, this column, has also been incremented just for the models that were purchased. So that's amazing. We're adding a row at the bottom, and this, so we can do not exactly a group by query, but a group by query is when you have a few different categories to group them by. Here we're just totaling them. So you can total columns in the array. So that's useful. And you could also just write values into a cell. So that's great too. So this is how you drop the table if it exists, and then save the new data into the table. Here's the table that we just filled. Right-click, select, and there's our data. We'll see you the next time. Bye.